Today we're gonna talk about Newton-Raphson method and its relation with Black-Scholes and implied volatility. So first of all, what is Newton-Raphson method? It is one of the numerical approximation methods used to find root of a function. Now, what is root of a function? Well, root of a function is anything that takes the value of x for which f(x) becomes 0. To understand this, let's take an example. Let's say there's a function f(x) x squared minus 4, and then I ask for what value of x does f(x) become 0. We would have said x is equal to, but let's say this function was something that's a little more complicated, then it would have been difficult to guess, right? So numerical approximation methods helps us find the value of x for which the function becomes 0. How? Let's say we start with an assumption. Let's say the value of x we guess is equal 3. So for that value, the function becomes 3 squared minus 4, that's 5. Now we can take a look at the slope of the function at f(x). X squared minus 4 would become 2x. Put the value of the x value that we have assumed and we would get 6. Now what does this 6 mean? Let's plot the graph. That's minus 4, it's minus 2, that's 2. So the graph would look like a parabola, right? Now this 6 means if we're standing at a point 2 for 3, we get a value of 5. As we can see, 3 and 5. So we know our coordinate points. Now what does it mean? We are 5 units away from x-axis, but also this lets us understand that if we were to move 1 unit away from x, the change in y-axis would be 6 units. So the 6 can be written as a vertical change divided by a horizontal change, right? Now what is our goal? Our goal is to take this f3, which is giving us 5, and take it to 0, right? We're 5 units above x-axis. We have to go back and make sure that the function converges to 0. How do we do that? Well, we know our rate of change, we know our f dash x, right? Now if we were to change vertically 5 units, we just need to know how much horizontal change we need, right? So for the same 6, we know we are going to change the vertical component by 5. We just need to know how much horizontal change we need. So horizontal change would become 5 by 6, right? What does it mean? We started with x equal 3. Our updated value right now would be take that 3 and deduct by 5 by 6. Why? We are trying to find a new value of x for which the function becomes 0. You would get something around 2.1. So this is called first iteration, this is second iteration. If you continue to do more iteration, you will finally see it gets closer and closer to 2, which is our actual value, right? If we were to formalize this Newton-Raphson method, our formula would look something like this. xn plus 1 is our updated x value, which depends on old x value minus your f(x) divided by f(x)n. So Why? Well, take a look at this. What did you do here? This 3, what is this 3? This 3 is your own original value that you took in the beginning. So that's your 3. And what is this 5? This 5 is nothing but the function that you got after you put x equals 3. So that's how you got 5. And what is this if dash xn? That means what is this 6? This 6 comes from your slope component. So our formula, the formula that we have generalized, matches, right? Now let's come back to why we need to know such approximation methods, right? Now let's say we are given a data for a stock, right? So for a typical data for a stock, we would be given a stock price, let's say 100. Now if we are given a strike rate, let's say, or strike rate can be 100, just assumptions, or rate is something like 5%, let's say time is something like 1 year. Now we don't know volatility. And why? If you see a formula for a Black-Scholes, you have a lot of components, right? You have your stock price, you have your strike price, you have your rate, you have your time, you have your volatility. But this volatility is assumed. You have to give the Black-Scholes formula a volatility, assumed volatility, so that you get the price. But what happens is, once you get the price, let's say Black-Scholes give you a price that's around 11, just assumption, these are not related to these values, I'm just assuming. But when you go to market, you see the market price is somewhere around 10.45 or something, right? There is a difference. Now why would this difference come? Because you have the same stock price, strike price, rate of return, time. The reason is your assumed volatility, which is causing this issue, right? What do you do in such a case? Well, since you put a assumed volatility number, you can always approximate it. How? You use the numerical approximation method. Now let's look at the formula we have already deducted, xn plus 1 xn minus fxn divided by f dash xn, and try to modify this formula to make sure we find the implied volatility, which makes sure the Black-Scholes price converges with the market price. How do you do it? What do we need? We need the Black-Scholes price based on an assumed volatility and the market price. We don't need this sigma, by the way. We don't need this. We need both of these values to become 0. So that's our function, right? We need these to be 0. Now how do we do that, right? Now we know our function, right? What do we need? We know this. We need to find derivative. So let's find the derivative. What is the derivative of this? D sigma, because we are differentiating with respect to sigma. Now D market price by D sigma. Now if you look at this, the market price is constant. It is not dependent on the assumed volatility change that we have put into the equations. Therefore this is a constant. This becomes 0. You have f sigma, that's dbs by d sigma. Now if you take a look, what is this? You have your option price that changes with volatility. What is this? This is called vega. So in the denominator here you have vega. So how would the function look like? How would the value of the numerical approximation method look like for this case? It would say sigma n plus 1 is sigma n, the value that we put initially. Now let's approximate in a way that it converges with the market price, the Black-Scholes price, right? So now we have here your this minus market divided by your f dash sigma, which becomes your vega. So that's the final formula. Why would you do it? You could find implied volatilities for a constant stock price, strike price, term and rate, and using that implied volatility you can take a Black-Scholes formula and you observe the market price and you can get the underlying volatility that's not addressed in the market. So that's the advantage of this process. Thank you.